Okay, so today we're going to do circular motion. A lot of it is review, so none of this should come as a surprise to anybody. Okay, what is a circular motion? Motion in a circle? It is specified by what? Having one radius that remains constant as you go around. What's the equation of a circle? X squared plus y squared equals r squared, where r remains constant as you go around in a circle. We also know in a circle, this is called the sweep, yep, arc length. This angle is called the sweep angle. This is the radius, and we usually represented arc length with S, the radius with R, and the sweep angle with phi. So we can write S equals R phi. When S equals R, phi is what we call 1 radian. And the angle 360 degrees equals how many radians? 2 pi radians, where pi is 3.14. So we can also say that this is equal to 1 revolution. And 1 radian is how many degrees? 57.3 degrees, or 0.159 revolutions. For things moving in a circle, even when they are going with a constant speed, their velocities are constantly changing. Agree? Because their directions are always changing. So that means even with a constant speed, velocities are changing because their direction is constantly changing. So that means we can define 2 different things. One will be center-seeking forces that go inwards that correspond to centripetal force, Fc, which is equals to MAC, which is equals mv squared over r. We also have what is called the tangential velocity or tangential speed. Vt, which is the speed by which an object tries to move away from the circle. And what is tangential speed? So note this carefully. We wrote S equals R phi. If I take the derivative of this equation, A, S equals R phi, and I differentiate with respect to T, I will get ds over dt equals r d phi over dt. This is called tangential speed. And this is defined as angular speed. Okay? So the way we write them is Vt equals R omega, where Vt, be very careful, if this is my circle, Vt is the tangential velocity, and omega is how much this goes around. It's the sweep as it goes around. Whereas tangential speed is the speed that it wants to go away from it. So if you let go of it, it will go tangentially away. Good? Okay, now I can also differentiate it again with respect to time. So this is written as dvt over dt equals r d omega over dt. This is called the tangential acceleration, and this is called alpha, the angular acceleration. Why am I being so specific about this? The reason why I'm being so specific about this is because I want to make sure that we do not get confused between centripetal and tangential acceleration. They are two different things. Got it? The centripetal acceleration is AC v squared over r, whereas the tangential accelerations are given by this, where AT is d squared s over dt squared, and alpha is d squared phi over dt squared. Just reminding ourselves, right? Yes.
What's the difference between the angular acceleration and centripetal?
So here, good point. Let me do one other thing, and it may help explain it. So this one, can I rewrite this as AC equals VT squared over R? This means this will become R squared omega squared over R. So I'm using equation 1 here. So that means my AC becomes R omega squared. So the relationship between AC and VAT is this. So this versus that. Centripetal acceleration is the acceleration that pulls it towards the center. Got it? And it has to do with omegas. Tangential is what makes it go outwards.
And the AT equals R alpha.
Yeah.
You said that's angular acceleration. The alpha
Yes.
is angular acceleration.
Yes.
So would that be the same thing as total acceleration? Like an angular acceleration centripetal is the same thing?
No, because this is so this one will be R d phi over dt whole squared. Whereas this is d squared over dt squared. They're not the same. Right, so everybody understands the difference between this and that, right? This is where you differentiate it once and you square it. Whereas this is where you're taking the differential again. Be very careful. These mean different things. That was a good question. Units. We didn't talk about units. So let's summarize. Angular displacement delta phi is given by phi 2 minus phi 1. Angular velocity is given by omega equals delta phi over delta t. Instantaneous angular velocity is given by d phi over dt. And the units for this is radians. The units for this are radians per second. The units for this are radians per second. And again, angular acceleration will be alpha equals d omega over d delta t. And instantaneous angular acceleration will be d omega over dt or d squared phi over dt squared with units radians per second squared.